So this was what we did by using the method of characteristic equation. All right, so what if you are using the Laplace to do that? So now you can go ahead, given the initial conditions. When you find this, right, given the initial conditions is that s at a naught is equal to, you put a 0 here, put a 0 here, 0 here, and then no, this will be a 1, and then the t, because remember this is 0 and t is 0, but x of 0 is a 1, so 1 equal to c1 e raised to the power t 2 times 0, that. So when you do that, you try to solve the constants c1 and c2. So let me kind of demonstrate that. So now you know that when you do x of a naught, it has been given in a question that s of a naught is a 1. Okay, so 1 is equal to, so s of a t means t is 0, so wherever you see t, you put a 0 there. So you have c1 e raised to the power, right, 2 times 0, isn't it? All right. Then we'll have plus c2 e raised to the power negative times a 0, isn't that? So what happens is that we'll have 1 equal to c1 plus c2. All right, so that's what we get. This is the first equation. We call this equation 1, right? Now we'll get our second equation when we use this second condition. It says that s prime of a naught, all right, we are saying that that is also equal to a 0. So it means you have to find x prime of a t of this equation, which is basically x prime of a t of that equation is basically equal to, we are differentiating this with respect to t, so 2 will come down, so we have 2 c1 e raised to the power 2t. all right, then remember negative 1 will come down, so we have minus c2 e raised to the power negative t. All right, so now we are trying to find s prime of a naught, so it means s prime of a naught, which is 0, is equal to 2c1. remember that when we put a 0 here, this goes to a 1, minus c2. all right, so this is the second equation, this is equation 2. So when we solve equation 1 and equation 2, then we'll get our c1 and c2, then we just plug them inside this and that, and we get our solution. So which has been done, and then this is c1 and this is c2. all right, so now what if we are trying to take the Laplace? What happens when we are trying to take the Laplace? Okay, yeah, so when we are taking the Laplace, what we are saying is that you have to know the Laplace transform of, remember that the equation is x prime prime minus x prime, right, minus 2x equal to a 0. So what we have to do is take the Laplace of x prime prime. What's the Laplace of x prime prime? So Laplace of x prime prime, you have to know. All right, so you know them by heart. Laplace of x prime prime is giving us x prime prime. Let me write the other prime. X squared, then capital X of x minus s, then s of a naught, then minus s prime of a naught. All right, then you have to know the Laplace of x prime. So Laplace of x prime is just x, capital S of x minus x naught. And the Laplace of x is capital F of x. Isn't it? So you just take the Laplace of everything like that. And you try to, your motive is to try to make capital F S of x the subject. So making capital S of x the subject gives you something like that. But remember, in the question, this has been given and this has been given. So to solve this, simplify this, you have to know this, guys. So this was given as a 1, this was given as a 0. So the top becomes x minus 1 and that. Right? So the top just becomes, now you just have s of x now becomes x minus 1 all over s squared minus x minus 2. So this is what you have. So remember that this is a solution, but just that this solution is in terms of x. Okay, this solution to the differential equation, but this solution is in terms of what? X, a Laplace component. So we have to change this back to our x and t's, and to do that we need the Laplace inverse. Okay, the inverse transform. We have to take the inverse of this. Take the inverse of that. So to taking the inverse, we try to, so if you're forgetting how to take Laplace inverse, make sure you review, watch videos on them, review, because this we are using to solve the equations. So if you have issues there, we can't actually be visiting that place because it will take a lot of time. Okay, so go there and then review how to take Laplace transforms. So this is a quadratic equation, try to solve it, and then you have a term like that, you have a term also like that. So you try to compare these terms to some of the known things we have, but you remember you don't have a, you don't have b, so you have to use partial fractions to find a and b. All right, so this has been done, and then I think this is what you got, right? So they use partial fractions to find a, and then a is 1 over 3 and b is that. So 1 over s minus 2, what's the Laplace of this guy? Laplace inverse of that is e raised to the power 2t. And the Laplace inverse of that is e raised to the power minus t, which is the same as what we got in the other one, isn't it? Okay, that is that. So that is that. So another example, we have x prime prime and x plus x equal to sine 2t, and then we know x naught is a 2, x prime at a 0 is a 1. Used by Laplace transform methods, we are solving this. So first I have to take the Laplace transform of x prime prime, which is x squared capital S of x minus x naught minus x prime x naught, right? And remember, this is the Laplace, this whole thing you see there is the Laplace of x prime prime. And then what's the Laplace of x is just capital S of x. So now what's the Laplace of sine 2t? Remember we said sine bt is b over x squared plus b squared. So sine 2t will be 2 over s squared plus 4, right? So you try to make capital S of x the subject. So capital S of x is given as that, alright, is giving us the whole of this. When you make it a subject, you get something like that. So this is the solution, but just that it's in terms of x, so you have to take the inverse transform of that. So remember, the most appropriate technique is use the partial fractions. All right, so try to perform partial fractions on this. We on this side. So learn your partial fractions, otherwise you would face problems. Learn your partial fractions. So I think going through that gives you the whole of that, and then we end up getting our s of x as that. Okay, this S of s as that. So for vivid description on partial fraction, if you want to go through the partial fraction again, remember I recommended a book, and I'm saying that this is the book. All right, so you can come to Laplace transforms, and then here it gives a detailed interpretation of how you can take Laplace transforms, right? So you want to take a Laplace transform. So it starts by telling you that probably you get a function like this. You have a function like this which doesn't look very continuous. There is discontinuity. You want to take the Laplace. Okay, so this is a typical example how they took the Laplace. You go through this book and send your issues on board so we can see. All right, so this is how they computed the Laplace, and we did the same book where it is treated how you can get the Laplace inverses. All right, so if this is the Laplace, how do you take the inverse? I think that has also been done somewhere. All right, so make sure you visit them, and then you'll be fine. Okay.